In this video, we'll explore how to use Cramer's rule to solve a system of three equations and three variables, or three variables and three equations, however you want to phrase it. All right, so the first step is going to be to write our augmented matrix, just like before when we did the 2x2 example, or the two variable, two equation example. So I'm just going to write our coefficients. So 2, 5, 1. The augmented matrix also includes the right-hand side of the equation. Make sure you include that. Okay. So first thing we want to do with this augmented matrix is calculate our determinants. And we're going to have 4 different determinants to calculate this time. So remember, the D determinant is just the coefficient matrix, the determinant of the coefficients. So everything to the left of the bar. So it's going to be 2, 1, 7, 5, negative 1, 1, 1, 5, 3. Okay. To find the determinant, we can use technology, or we can use our shortcut technique of doing writing the first 2 columns again and doing it that way. For demonstration purposes, I'll use that technique. So I'm just going to write the first 2 columns again, and then go diagonally down this way, and then go the other way. So going diagonal, we have 2 times negative 1 times 3 in that first diagonal, and that gives you negative 6. The next diagonal is 5, 5, and 7. So let's see, 25 times 7. Let's take out a calculator real quick. I think it's 175. Yep, gives me 175. And the last one, 1 times 1 times 1. That gives me, of course, 1. Okay, next we want to subtract in the other direction. So let's see, multiplying this way, 7 times negative 1 times 1. That just gives me negative 7. Next, 1 times 5 times 2, that just gives me 10. And then the last one, 3 times 1 times 5, that gives me 15. All right, so let's add these. Let's see, this gives me 170 on the first one, minus, let's see, negative 7 plus 10 is 3, 3 plus 15 is 18. And so this total here would be 152. Okay, now let's do this again, where we're replacing remember, this is the X column, this is the Y column, this is the Z column. Replace all the coefficients on X with the right side of the equations. So replacing that, the right side of our equation with the coefficients on X, or rather the other way around, replacing the coefficients on X with the right side of our equation. We get the matrix, we'll get the determinant dx, which will be the determinant of the matrix. Let's see, instead of 217, we're going to replace it with 25,3. And then the rest of this will be the same. Again, just for practice purposes, we could use technology to find this determinant, but let's just do the shortcut method. I'm going to rewrite those first 2 columns again. All right. Going diagonally, 20 times negative 1 times 3. That gives me negative 60. 5 times 5 times 3. That would give me, let's see, 75. And then 1 times 5 times 1 would give me 5. Okay, next I want to subtract the other direction. 3 times negative 1 times 1. That gives me negative 3. Add to it 20 times 5 times 1, which gives me 100. And last, 3 times 5 times 5 again gives me 75. Okay, let's add and then subtract. So adding the first group together gives me 20. And then the second group added together would give me, let's see, 175 minus 3 would be 172. So 20 minus 172 would be negative 152. All right, so if we want to calculate x, remember the formula is just going to be dx divided by d. So that's just going to be our dx, which is what we just calculated, the negative 152, divided by the determinant we calculated a moment ago, the d determinant 152. So that means our x value is negative 1. All right, so let's do the same procedure for y and for z. Okay, so let's not lose our information here. We obviously don't have to recalculate d anymore, but this was our original matrix. Remember, we calculated d before to be 152, and we're going to need that for y and z. Remember, y is just going to be dy over d, and z is just going to be dz over d. All right, so let's find dy. So dy would be the determinant of, we take our right side and replace the y column, our second column, with that. So that would give us, let's see, the first column is now going to be the same. It's just going to be what it was originally. But instead of 5, negative 1, 1, we're going to replace it with the right side. And then we're left with the 1, 5, 3. The z column remains untouched because we're not solving for that. Again, if we're doing the determinant by hand, just for practice, let's rewrite those first two columns and do the math. Okay, so going diagonally down, 2 times 5 times 3, that gives me 30, I believe. Okay, 20 times 5 is 100, times 7 again. That would be 700. Just double checking myself, yep. And then 1 times 3, that is, of course, just 3. Okay, let's go in the other direction. 7 times 5 times 1, that's 35. 3 times 5 times 2, that would be 30. And 3 times 1 times 20, that gives me 60. Okay, let's add these all up and then subtract. So this gives me 733 minus, let's see here, 65 plus 60 is 125. Okay, let me just take out a calculator real quick. So we have 733 minus 125. That gives me 608. So that means y is going to be dy over d. So that's going to be 608 divided by 152, which is just 4. Okay, now let's do the same thing to figure out what z is. So we need to figure out what dz is, which again, we're just going to take this last column here and replace it with the last column of the coefficient matrix. So let's see, we have 217, that remains unchanged. 5, negative 1, 1, but instead of 153, we're going to replace it with the right side. Okay, let's rewrite the first two columns. And then we can find the determinant. So going diagonally, we have 2, negative 1, 3, which should just give us negative 6. 5, 5, 7, multiply those, gives me 175. 20 times 1 times 1 gives me 20. Okay, then we're going to subtract in the other direction. So add all these up. 7 times negative 1 times 20 gives me negative 140. 152, multiply those, gives me 10. And 315, multiply those, gives me 15. Okay, let's add this up. Let's see. I think that's a 75, right? So this gives me 195 minus 6, which would be 189. And let's see, we have negative, sorry, we have negative 140 plus 10 plus 15 gives me negative 115. Of course, subtracting a negative is the same as adding, so 189 plus 115 gives me 304. So Z is going to be the ratio of these. So it's going to be DZ over D, DZ being 304, D we calculated before to be 152, and this would just be 2. I somewhat ran out of space here, but putting this all together, our solution to our system of equations is going to be the X value is -1. Remember, order triples we write as X comma Y comma Z. Our Y value was 4, and our Z value was 2. So our solution to the system of equations is -1, 4, 2.